Good morning, good afternoon, and good evening. On behalf of Capstone Technology, welcome to day 2 of the 2020 Data Park Virtual User Conference. We're so all excited that all of you could be here to join us again today. And for those that are joining us for the first time, welcome, welcome. Yesterday, my colleague Molly got us started as the host of our conference, and today Molly's passed the torch on to me. So I'm going to be your host today. My name is Jacob Jakubik. I'm the project manager here at Capstone Technology. So welcome, and we're so excited everyone could join us today. But in case anyone's joining us for the first time, I wanted to quickly walk through the conference site just to make sure everyone's familiar. Just a couple of housekeeping items really quickly here. So we're going to go ahead and let's start on the screen you're looking at right now. On the right-hand side there, you're going to go ahead and see that chat box. This is going to be kind of the core of what we're going to be doing inside each one of these sessions. And so the chat box, it has two options. As you can see, there's going to be the black question mark to ask any questions, Q&A questions of any of our speakers, and the green icon the green chat button, for any type of general discussion that we have going on. So, any of those questions that you ask at any time during our presentation, we're going to wait until the end of each presentation to go ahead and review those with each one of our speakers today. So don't be scared, don't be bashful. We'd love any questions, any and all questions that you can possibly ask. All right. So now that we know how to chat, how do we actually access these upcoming sessions? And so really quickly, again, at the top of the page, you're going to find that home button. Go ahead and click on that icon. Oh, not right now. When you're looking to enter that next session, you're going to always go back to the home page, find the session that you'd like to join, and select the broadcast button, and it'll bring you back into our presentation here. So now that we kind of got our little bit of housekeeping out of the way, that brings us to our first poll question, or I should say the poll question of the day. And so what we'd like to do is in that chat box that we just described, there's going to be a link there to the poll question. It just showed up. So go ahead and select on that. And the question that we're looking to have answered for us today is, which data park resources would you like to see more of? We'd love to get some great feedback from everybody. What makes it more effective to you? How can we make our learning possibly better, whatever that might be? Please go ahead and select that. And when we go ahead and take the poll, we'll go ahead and take a look at the results afterwards. So you hit that submit button, and the view results, we'll see what we're looking like. And so at the moment, we're changing a little bit, and as you see, it updates on the fly here, but it looks like webinars with let's see here. I'll give you guys a minute or so to answer that. All right, well, it looks like we got some good results coming in here. Webinars is still holding high. All right, excellent. Well, we'll take that wonderful feedback into consideration when, taking our next steps forward on how we're going to proceed. So thank you so much for your participation. We love getting that feedback back. And so that brings us to our first speaker of the day. And this is one that we look forward to hearing from every year at our conferences. Please help me in giving a warm welcome to Ron Baldus. He's our CTO here at Capstone and one of the founders of Data Park Software, as Jason let us know yesterday. He always continues to bring an interesting and unique perspective to the industry, and so we always love hearing from Ron. So if you guys wouldn't mind helping me welcome Ron Baldus to our presentation.
Hey, I'm here with you guys. Thanks for joining us. I'd rather be in person, but that doesn't work out this year. So I'm Ron Baldus. I'm Chief Technical Officer for Capstone Technology, and I've been with them since the beginning. What I'd like to cover today is what I've titled the anatomy of an app, and just kind of go through, as developers and working with our customers, what is it we're up against throughout time. We've been at this a long time, and sort of what walls are we up against now, and how are we trying to deal with that. So we have our customer opportunities. That's where it starts. The functionality is what we're after, as we work with our customers, and originally we were the customers. We lived it. It was our application for our use, and then we've been able to build that for other customers. And that's been a driving force. And so we need the functionality to solve our own problems, solve their problems. So that's the driving force. Then what we're after is, if we can get the functionality, that isn't the end, it's the ease of use. You have to be able to, we talk about minimizing clicks. I'm big on that. Fewer clicks, the better. You need direct data access. You can't fool around dragging data in and out of an app. You got to go live to wherever the source is. There needs to be interoperability between the tools. Interoperability, first time I've probably ever used that word, but it's appropriate, is we need the tools to work together. If you want to go from trends to histograms to an analytics tool, we can't be copying data back and forth. And it has to happen at the speed of thought. We've mentioned that in previous conferences, and speed of thought is important. You got to be close enough that keeps the person on track so that they don't have any, so they don't lose track of what question they're asking. So the roadblocks that stand in the way are compute power, RAM and speed, display, size and resolution, storage, how much data can you store, and the speed you can store it at. And network reliability and speed. So I'm going to try to put those in the context of what we are up against. And the trick here is we need to be ready as the power rolls in. We need to be ahead of the game enough that as the systems become more powerful, our customers immediately have access to that. But we can't get so far ahead that the customer spends a year or two going, I can't use that because it's too slow, or I can't get enough data in the system. So what we're after is eliminating those roadblocks or working around them as much as possible. So let's talk about them. One of them is CPU speed. That's, from the beginning, and a lot of these trends are going to be from 1980. That's when we started all of this. It happens to be that's where people go back clockwise because the first PC was developed then. So from 1980 on, the CPU speeds went up, and that saved development people because it was always too slow when you got the app, but if you waited a year or two or three, it would speed up. The clock would speed up. This is a logarithmic scale on the left, so we really had a lot going for us in delivering to the customer. However, around 2004, all of a sudden, we stopped. And if anybody who's been at this, we've been at 2.5 gigahertz, 3 gigahertz, or megahertz. We've been waiting for a little while to get higher speeds, but that has not happened because of heat issues. So what they have done though is, okay, let's put multiple CPUs, multiple cores in. So around 2005, that's about when we stopped getting speed increases. They decided, well, okay, we're not going to go faster, but let's start putting more cores in. Let's start adding more CPUs. So since that time, speeds really haven't increased very much, but they've started adding cores. So we're up to, now 6 to 8 cores. Servers and the like can have a lot more cores, perhaps, but the sweet spot is where you can get consumers using the level of development or hardware that you're at, and then the price drops a lot. So that makes it more affordable and more mainstream at the levels that we tend to work with customers at. So I don't know where that's going. We go up more cores, but it's not true that 2 cores is equal to doubling the speed, or 4 cores is equal to quadrupling the speed. It just isn't. Anybody who looks at your CPU usage, when your machine is slow and you say, why is it dogging? There's times it just can't use those cores as much as we try to parallel our operations, or anybody does. So it isn't a panacea that you just keep adding cores, although that does help. So that's RAM from a speed point of view. We're actually doing pretty good on the speed side for most of what we do in RAM. It tends to be a problem at times, particularly in the analytics. In speed, the RAM, they're up to 64 gigs now. You can put in a machine, and the 64-bit processing, we can utilize that. It's around what, $300 for 64 gigs. So price-wise, it's within striking range. So our memory isn't that much of an issue the way we use memory at the moment. So now I'm going to jump to display size. The display size is interesting in that anybody who remembers the 15-inch diagonal displays, you know, you couldn't put a whole lot on them. And we were dealing, when we started, there were 13-inch displays. So you can imagine our trends. We've had to wiggle them around, make them fit in that space for a long time. But as the displays got better and better and higher resolution, and 4K is the red one down here, that's kind of the standard where we're at now. That requires, we're looking at from an operator's point of view, what size monitor, 15-inch monitor, that fits so that if you get much larger display than that, now you start, you know, looking at pixel resolution and maybe seeing pixels. So that tends to be the sweet spot. And that's been all the way from the beginning. See, 7,000, these are the size, the resolution for the size monitors. 19-inch was a 1280-960, 27-inch is 920 by 1200, and that's what fit the best. Well, now we're at 4K, and that fits about a 50 to 55-inch display. So this is not our roadblock. Display resolution and size, man, they've blown that roadblock out of the way. We had it for years stopping us from doing what we needed to do, but that's not the case today. In fact, we're lucky because other industries other than ours drive that resolution, and that's what makes it cheaper and drives the development. If you take a look at an iPhone, for instance, for its resolution, it would take a 4K monitor. You'd have to put it on an old 17-inch monitor to get the resolution on an iPhone in pixels per square inch. So we've got a wide open field of being able to utilize the displays today. It's mostly our imagination that gets us in the way, not the cost and space to make it happen. For instance, if you take a look in the industry, and I go back to the original control panels. If you see here, here's an operator. It looks like he's got 4-unit operations. Because they're kind of duplicated. The panels look like they're reproduced. So whatever operation he's running 4 units, and each unit's on a panel. And that's the way it used to be down. Motor starts on the bottom, ammeters for the motors across the middle, and then whatever analog signals you had in the middle. And I made a statement here, in some ways I could operate better 40 years ago than today, because I actually operated 40 years ago for a bit. And these were the kind of controls we had. And I can't say that I operated better because we didn't have very many signals. For instance, we'd have analog signals. One operation I was running had 5 analog signals. And today that operation has 50. So of course you couldn't do it on a panel like this. But what the panel offers is pattern recognition, or you always know where everything is. That's not true today. Operators operate on screens that are continually changing. They're bringing out, they have maybe, for one of these operations, maybe they'll have 5 screens that I gotta go to. And that's always been an opportunity for us, I think. If you've heard me talk before, I think every unit operation ought to be on a screen. Everyone ought to have its own display with all the controllers on it. And that's really what they ought to control off. I mean, and they're getting better these days. They're going to that because they're getting better resolution for the operators, but some of them are pretty sad what they have available out there. So what you really need is something that looks like this. We need to go, I sort of believe in the panel, and I believe in the always having everything in front of you that you can for your operation, if that's possible. That's both from a graphical presentation and a trend presentation. And the point is that for young operators or communicating with different people, you can walk up to that board and it never changes. It's always in the same place, the things that you're looking at. So when a young person stands off to the side and they look at this and 2 people are having a discussion about a problem they're having, the transfer of that information is 10 times in this situation for people being trained. It just has so much going for it in the long run. They can operate off this panel. The other thing is that you get a physical proximity to when you walk up to an operation and you're always going to the same location to turn something on or off, that reinforces how that whole operation is hooked together. And so training and then troubleshooting, it makes a big difference. And of course, I'm a big trend guy. The trends on the top are really important. So if you had this kind of an operation, you'd take advantage of, let's get it all visible in front of us. Although real estate's a problem, not so much cost or capability of the screens, but real estate is. So if you redesign a control room, they had real estate in the past, and if you look at it the same way, you could have real estate. With existing control rooms, you may not have that flexibility. And hey, who knows? There's a ceiling up there. I liked the old alarm panels. If you look at them over here, they had the buttons. They were squares. We got 6 main alarms. It's really nice. It used to be when alarm went off, you instantly looked. That operator instantly knew. You didn't have to go anywhere else. It was so, the ceiling's wide open. It can be angular. We use it now to hang monitors from, but it's not the same. So I'll throw that out as hey, there's always a possibility of, hey, we're not thinking about the full capability of the hardware that's available. Network speed doesn't seem to be as much of a problem anymore. We're heading, for the kind of work we do, it's not bad. For people who want to play Minecraft, and they're the ones driving it. Same way with the screen resolution. We're lucky. We need that mass consumption out there to drive up speeds and resolutions, which it's doing for us. That gets the price down and provides more driving force than just industry would have. So what do we have? 5G's coming along. It isn't just you can be wired up. You can be wireless. We don't necessarily think of all the possibilities that brings up for us. But most people are positioned, or hey, if you give us 5G, we'll take advantage of it at the moment. And who knows? We have many facilities that our customers have that are out in the middle of nowhere. They don't necessarily have good internet access. Well, Musk, last Wednesday put up another 60 satellites. I don't know what kind of throughput he's going to get. Nobody's saying, but boy, that'd be nice to blanket the area. So a lot of the sites that we have poor access to, we would have full access to. So networks, they're going at the right speed. They're coming along. I don't see that as being a stumbling block for us. Storage wise, that's kind of another, disk storage, that's another issue. From a volume point of view, we're doing really good. Sorry about this, and this only goes to 2010, but it continues to go right off the chart. Disk space continues increasing. I don't know how they do it, but that's not stopping us. Not a price issue. So we don't have to worry so much about that in our industry. Again, the whole internet and Google and everything they're doing, and Amazon, they've got so much disk space. They're driving that disk price down in development. So we're just riding the tail of that. So size isn't a problem, but speed is certainly a problem. If you take a look, the hard disk drive was 7,200 RPM, introduced 28 years ago. Seek time was maybe 20 milliseconds, now it's 10 milliseconds. That's 28 years ago. I'd be willing to bet 7,200 RPM drives and they have 10,000 RPM drives. They're not that much better. They're a little better. And so there's a little faster, but we just haven't done anything for a long time in that with the hard disk drives, because they just aren't going to go faster. So what that means for us is if we look at a trend, I just did this the other day because I was called in to look at an issue or on a process. And this site had a third-party historian, another historian, and I had to look at 20 tags to figure out what was going on. I needed to look at the last 4 months. Well, one tag, it was second data. For 4 months, took 8 minutes to bring the tag back. I mean, if I have to look at 20 tags for 8 minutes, I might as well, go scrub the kitchen floor or go mow the lawn while it's doing it. And hey, we're home these days, so I could go do that, but it drives me nuts. I couldn't get anything done. So that's what we've been stuck with here for the last 10 years, really. So what people do is dumb it down, and they go to 1 minute data or 2 minute or 3. Then you can't do the troubleshooting we normally do. So here's where we have tried to take control of it a little more with what we can do. We can't speed up the disk drives, but we can definitely be an intermediary. So Park Aggregate's huge for much of the process engineering we do. It's the only thing that makes it livable and for us to be able to troubleshoot the way we do. So you can, that 8 minutes went to 5 seconds or 3 seconds. And if you apply other parts of the Park Aggregate, it's 1 second. So we've been able to get over that hurdle. We don't necessarily want to do those things, but if it's a difference between succeeding or not succeeding, that's what we're going to do. If you take a look at SSDs, they came along. So you're saying, hey, wait, you know, the 7200s are out there, but the SSDs here, and I don't know if you know it, but the S7200 RPM was introduced 28 years ago, and the first SSD, I think it's 20 megabytes, was introduced 28 years ago or 29 years ago. It took a long time for it to become viable for us, but hey, it's here now. It will replace the hard disk drives eventually, but the hard disk drives keep getting bigger and people want to dump more data, and they seem to be getting bigger faster than the SSDs, but the SSDs are going to rule. So I don't know, I've had a hard time figuring out, you know, the speed increase that gives us. You know, originally it was 2, and then 3, then 5. Let's just say it's 10 times the speed. That's really helpful, 10 times the speed. But still, it takes that 8 minute to about 1 minute for a tag, and it takes 5 seconds to half a second. So, but we still are not going to be able to just stick with the raw data. We've got to have the intermediary to make it work for us. But the SSDs will really help. I don't see anything on the horizon other than RAM disk, and that's what some of the cloud systems, they're very expensive to run your analytics through that. But hey, if you throw all your data in RAM, it's probably 10 times the cost or 100 times the cost of what I believe anyway a solid state disk or HDD would cost. So this is one of our biggest problems. Here's where software are trying to work around the problem. 20 years from now, we'll go, why are you doing Park Aggregates? You don't need that anymore. That'd be great. But until then, that's making us succeed in our engineering lives. So if you take a look at the wrap up of, we've got these 4 items. There's 2 of them that are red. The compute speed, we definitely can use more compute speed. It's not hurt at killing us now, and primarily for the analytics would help us. And then storage is one that can kill you. If you don't fix the speed problem and have the ability to get at the data, you cannot do the speed of thought. And so it's both ease of use, it makes a difference, and with the analytics, we're ready. We can do a model in, you know, a soft sensor in 3 or 4 or 5 minutes, given if it's, you know, 10 tags, 15 tags, and months worth of data. We can do that but we want, with the deviation detection, we want to put 10,000 tags in. We don't want to have to think about anything. Well, when you start loading up with that kind of thing, you don't get that speed of thought return on what you're wanting to do. So we've had to step in the Park Aggregate. And Park Aggregate can work on any historian. It is not just our historian. I think people don't understand that. And it's just really valuable. I think sites have it and they don't even know it. You need to check that it's turned on if it's there. So where we're at, as I said, the trick is to be ready as the power rolls in. And we're ready. I mean, we can take advantage of all the power thrown at us. Particularly the data park analytics. We can really use a tool right now, but I got to thinking, you know, if they had quantum computers and they were 1,000 times faster, will that make any difference? Yeah. Yes, it really would, because we still play games to try to narrow down the data a bit to make it fit, to make the speed of thought work for us. So when the power comes, you know, we're ready. Data park's ready. And I'm going to go back one more time. And every time I do one of these, I kind of harp on this. If there's any process people or, you know, managers or whatever out there looking at this, it'd be really interesting to see what a new control room design would look like if you really thought out of the box and took advantage of the hardware that's available. So that's wraps up sort of where we're at in app development. You're going to hear a lot of several other presentations that talk about specifics of what we're doing, but that's sort of an overall 10,000 foot picture. And are there any questions for me?
All right. Well, Ron, thank you so much for that excellent kind of overview of technology. We have some really exciting things coming up, obviously. One of the questions we got while we were, during the presentation was, are there any plans to use GPUs to offset the CPU's lack of growth in the coming products?
When it becomes sort of mainstream for us to be able to take advantage of it, we'll do anything we can, particularly on the analytics side, of course. Not so much on the user client side of things, but when it comes to analytics, we've got to ride that wave as it comes in too. So we'll take advantage of it as we can.
Excellent. And that really kind of wraps up our QA today, Ron. I loved that. I don't know if you heard this in the news, but they're talking a quantum computer in every home in 5 years. So, yeah, exactly. The day we see it, the day that it happens.
Yes. Well, hey, we're ready. That's all we're ready for that. So.
Absolutely. And, the improvements in 5G and everything that you hit on, I try and sit there sometimes after work, like, what can we actually do with this tech? It's absolutely phenomenal. What an incredible opportunity, connecting cars, traffic lights. I mean, anything that you have, it's really awesome. So yeah, I'm really excited to see what we might be able to do with that as well.
Okay.
All right. Well, Ron, thank you so much for everything. That really wraps up our QA for today. So yeah, we really appreciate the presentation, and thank you for all the questions that we got there. And so that kind of brings us into our first round of trivia for today. So we did have, we had fun with our trivia yesterday with Molly, but I couldn't let her be the only one actually offering the trivia. So I had to, come up with a couple questions here. But before we get started, I just want to go through really quickly with how to compete in this. This is a game of quickness. So what we're recommending to everybody is, if you want to go ahead and pull up an email on your phone, and you can leave everything on your computer, so you can still see my lovely face, but go ahead and bring up a new email. And the way you're going to answer is, you're going to send an email to tlamb@capstonetechnology.com. We've added it to the chat box there. And again, it's tlamb@capstonetechnology.com. And so what you're going to do is, you're going to provide your answer in the subject line. And whoever can hit that send button first, whoever lands in Tanya's mailbox first, is going to be the winner. And today, we do have a $50 Amazon gift card, as well as possibly some other things available. And we will be getting that sent out after the the user conference wraps up. So be looking forward to that. So I wanted to make sure, I'm going to give you a couple seconds to get the email prepared on your phone. And so I'm going to give you to the count of 5, and I will ask the question. So if everyone I'll give everyone a couple more seconds to get everything ready. Again, email the tlam@capstonetechnology.com. And the question that we are going to have for our first one today is, marble is formed by the metamorphosis of what rock? Again, the question is, marble is formed by the metamorphosis of what rock? So go ahead and answer quickly. And again, we'll have those results a little bit later in our conference here. So give everyone a second here to go ahead and do that. Again, just really, really quick. The question is, marbles are formed by what metamorphosis? Formed by the metamorphosis of what rock? Marble is formed by the metamorphosis of what rock? All right. Well, excellent. Thank you so much for your participation. Now I'm gonna give you about a 10-minute break real quick, and we're gonna be back here at 8:40 a.m. Pacific time. Again, just a quick reminder, go ahead. We're going to have you head back to that homepage and select that next session when we at 8:40. So we'll look forward to seeing you back here. And thank you so much.